Okay, Tommy, this video is finishing the axle part that we did in the last lesson. I had some technical issues during class, so I was unable to record it live then, so you won't hear any of your fellow students talking in the background this time. So you'll want to launch SolidWorks. So yeah, I'm recording this at home, is basically what I'm saying. All right, with SolidWorks open, you should be able to browse your recent documents and find your axle that you were working on. And we left our last lesson trying to make these two flat cuts at the bottom of this part. And we had created two rectangles and we need to do a little more work on them. So this sketch here at the bottom, this one with the undefined symbol next to it, we need to edit that sketch and go normal to it. And one of the things we need is for this line and this line to kind of line up with each other. Or another way to think of it is this face and this face could be equal. I'll show you both ways of making these two boxes remain equally spaced across the center here. There are like 6 different ways, but I'll show you 2. One way would be to click this point, hold down the shift button, click this point, and add the vertical relation. And that would, if you just did that, force these two to be in sync like that. Another possibility, and I'm just going to hit Control Z until that goes away. Another possibility would be to click this line and hold down Shift and click this line and make them collinear. That would also do the trick. Click check there, and that makes them, because this line remains aligned with that one, that would do it. Also, the last way I want to show you is you could click this line, hold down the shift button, click this line, and give them the equal relation. Click check. All of those are different ways of achieving the same basic goal of making these two rectangles remain equal in size and aligned properly. The last thing to do is, if you were to take a look at your drawing that we gave you, at the very bottom of the diagram, there's a circle that shows this view of the part, and it actually has a smart dimension. It has a dimension there from this surface down to this surface this way. Oops. All right, and you see what happened here. It's worth noting. I already had the edge of this circle selected when I launched the smart dimension. So then when I click this and this, it's trying to do some weird dimension. I don't even know what this symbol is. If that happens to you, just hit escape a couple of times until nothing is selected. You might, if you hit escape too many times, it might turn off smart dimension. But make sure smart dimension is still on, nothing is selected, and then click the 2 lines and pull over to the side. That distance is 0.3125 on the diagram. And so this is properly dimensioned and has all the right relations. It's fully defined. So that's, those 2 rectangles are complete. Exit the sketch, and then we need to do an extruded cut. And if you look at, oops, I need to make sure I've got it selected before I launch the extruded cut. If you consult your diagram, you'll see that this cut has to extend up this direction, that arrow's pointing, by a distance of 0.3125 or 3/8 of an inch. Oops, delete that. 3/8 of an inch. So if you click check there now and check a second time. So now this part has these flat surfaces on it down here at the bottom, just as the drawing suggests. Earlier, I had suggested that we were finished with the top portion here, but I had misspoken. I had forgotten that this corner right here and this corner right here are not actually square corners like that in the part. If you consult your diagram, you'll see that actually there's like this half circle that terminates this slot as it comes down in this direction. There's a reason for that. It has to do with there's no real way to manufacture this to have these sharp edges, or no easy way to manufacture this to have these sharp edges. It's usually done by taking a round cutter and cutting along, and so this would terminate with a half circle down here. The way we're going to do it in SolidWorks is we're merely going to apply a fillet. So as you remember, fillet's one that doesn't require sketch. So we'll just click fillet to launch the fillet tool. And as I pointed out, there are actually 4 kinds of fillet possible. We usually use just the first one, which is a constant radius fillet, or we use the last one, which is a full round fillet, which is what we want in this case. A full round fillet, what it does is it applies, it figures out what radius of curvature would be able to start off at this surface, just touch that surface, and then continue curving on around to touch this surface. It's tangent to all 3 of those surfaces. And SolidWorks figures out what dimension that needs to be, so you don't have to worry about that. So we're going to launch the full round fillet option, and be sure you've got full preview selected. There are 3 boxes here. Each box has to have 1 entry for this to work properly. And essentially what they are is the blue box is one side, either this side or this side of the space you want to put the curvature in. The purple one is always the one between the other 2 sides. So it'll be this one right here. That's where the circle just touches tangent. The half circle touches just tangent. And then the pink one is just the opposite of the blue one. The pink one and blue one are just opposite sides. So in this case, while that box is selected there, see it's in blue, that blue interior that tells you that's ready for an entry, we can come over to our design space and click on that face, and it enters that into that box. And we can click this next box here. Now it's waiting for that entry. I click that. There's your purple box. Then click this for the pink one, and we have to rotate the part around. So you'll middle mouse click and drag, or scroll button click and drag to be able to see this side. And then when you click on this side, it selects it. And there's our preview. I'm using my scroll wheel to move that around. There's the preview of that, which is precisely what we want. Click check. That part is complete. You've now finished the axle. It's properly dimensioned in relation. One thing I want to point out for future, when I give you problems to work and I'm going to be grading them, is one of the first things I do is I click these little down arrows next to any of the bosses or cuts that we do. I won't bother with the hole wizard items or the fillets. The fillets don't have an option for an arrow anyway. But all the others, these were all features we built off of sketches. And what I'm doing right now is I'm just looking to see, are all your sketches what we call fully defined? Perhaps you remember at the beginning of this lesson, there was a negative sign next to this word sketch 7 in parentheses. It was a negative sign. What it would mean if one of those symbols shows up is that you have not fully defined the sketch. That part of it was still blue, part of it was undefined or underdefined. Just to reiterate that, you wouldn't want to make this change to your part. But I'm going to edit the sketch, go normal to it, and I'm going to delete this distance for a minute. Hit the delete button. Now you see all that blue, that's undefined or underdefined. So when I exit the sketch, you now see this symbol right here next to that sketch. That's saying it's undefined. So when I'm grading stuff, one of the first things I do is I look to see if all your sketches are fully defined. So you should not have one of those appearing anywhere in your work. I'm just going to put this number back in here. Oops, I clicked the wrong thing. Let me click the red X. Control Z that away. Control Z again. There we go. Smart dimension from here to there. There we go. 0.3125. Perfect. So I've restored that to now being fully defined. That's pretty much it for this part. What you'll do next, Tom, is you will start on the physics bracket part that I sent over. There's a JPEG, I think it is, or maybe it's a PDF of it. I sent, I think, the first email. I do want to talk about that part for a little bit and show you some of the tricks for properly putting in the relations that are desired for a part of that type. So be sure you click save on this. You'll have this in your portfolio when you get back to school, and we can put it in the portfolio for you to refer to it if you ever remember how you made something or did something. Close this part. And I'm very quickly going to show you the first few steps of that machine part. Give me a moment. Let me see. Where did I don't think I have it on this computer. that part. So I'm going to make up my dimensions. But let's say we start the part on the top plane, and we'll use a center rectangle to keep our origin right in the center of the body of our part. I believe it's about 1.2 inches in the longest dimension, and I think it's 0.9 inches in this dimension. I'm not entirely sure. Again, this is from memory. No, that doesn't look right. Maybe it's like 0.7, maybe this way. That looks about right. I'm just guessing. Anyway, escape that, and then I can extrude boss base this. I'm going to do it mid-plane because I just like having my origin right in the middle. And I think that's also about 0.7 in that direction as well. I could be wrong. It might be like 0.8. I don't know. Anyway, essentially, you've created this box. Now, one of the things you'll notice about the part, if you look at it, is that it has these squarish looking cutouts in them with little triangles added to the end. Let me show you what I mean here. I'm going to make a sketch here. I'm going to use a corner rectangle with one corner on there and the other corner out here somewhere like this. And remember, this is implementing the idea of simple sketches, multiple features. So this is while the shape actually has an additional triangular cut in it, starting out with just the rectangle part, and then I'll cut the triangle part out later. Here's the thing I wanted to show you. We really want this to be centered on this face. We don't want it to be, you know, off center, like up here and like this. You could, if you had the part in front of you, measure the distance from this edge up here to this edge right here, and this edge up here to this edge right here, and type that in as a dimension to kind of attempt to get this to center. But if you found out your dimension of this line here, this length was different, and you changed it, that would make this go off center. So if you want to keep this centered on this face, there's a ability in SolidWorks to select the midpoint of a line. And if the midpoint of this line could be made horizontal with this origin, then it wouldn't matter how big you made this part or how big you made these cuts, it would always keep this rectangle centered vertically here. So here's what you do. You hover over a line and you right click on it, and the option select midpoint comes up. If you click that, now you see that midpoint's in blue. If I hold down the shift button to allow me to select a second thing and click the origin, now I have both that midpoint and the origin selected. And if I add the horizontal relation, click check, this is always going to stay aligned in the middle. You can't really move it anywhere where it isn't centered on that part. Because the origin was in the middle here, and this midpoint is horizontal to that, this will always remain equal distance on this side and that side without using any dimensions. Now, there are some dimensions you do need in this part. I think they're given to you. The width of this way, I believe, is given. I think it's like 0.6, something like that. I don't really recall. Nope, it's not that much. Maybe 0.45. Let's see. Yeah, it's probably about like that. I mean, proportionally, this looks right. In a similar way, the length this way is also given to you, and maybe I'm going to put in 0.3. I don't know what you really have. But see, simply by putting those two obvious design intent things, how wide do we want the cut, how far do we want it to go this way, we orient that rectangle. I can escape that and do an extruded cut through all. I've got the cut. Now, again, it's got a little triangular cutout next to it here. So to add that, we can right click and start another sketch and just use the line tool. Now, here, be sure you do not choose center line. You want line in this case. Center line would not extrude, but line will. And so you're going to turn on the line tool, click once here, once up there somewhere, once down here. And then this is important. You have to close this figure. You got to come over and click there a third time. You'll notice how this now has a, notice how this figure now has a kind of a shaded interior. That's telling you you've done something right. If it did not have that shaded interior, it means you've left what they call an open contour. And the problem with an open contour is SolidWorks isn't really sure what you want to cut. If you just drew a line, don't do this, but if you just drew a line like this, okay, that little line right there, it doesn't know whether you want to cut on that side of this line or this side of this line, or whatever you want to do. So anything that's not closed is not going to have that shade in there. I'm going to delete this line now. Click on it, delete. But you know that you get the point. You have to close a figure before a feature will work. You can certainly make a sketch that's an open contour, but you'll never get it to extrude, or at least it's exceptionally difficult to get it to extrude. All right. The next thing about this guy we drew right here that's important is I'm going to want to make this side of this triangle and this side of this triangle equal. So I'll click on that one. Hold down Shift to click on that one and make them equal. And next, I want this to lie not over to the left this way or the right this way. I don't want to have it left or right. I want it centered on this line here, which is the same as centered on this line, fortunately, so it makes it a little bit easier. So what you're going to want to do is you're going to click either this line or that line. It really doesn't matter which. Right-click on it, select midpoint. Hold down the Shift button, click on this point here, make those two vertical, and now you can see that's going to remain centered on here. I can dimension the depth of it, and I can dimension the width of it, but it's always going to stay there. I don't know what the depth of it really is, and I think it's probably given in this way. No, not that. Make sure I can escape until those are unselected. From here to there, it probably gives you that number. I'm not sure. I don't remember what it is. And then it might give you the length of this line here. It might be something like that. So those two, again, very clear dimensions that you could measure if you had the part in front of you are all you need to define and locate that. It's a fully defined thing. And again, you would do extruded cut and through all. One last thing I want to show you on this part to help you with it is there's also a triangular cut on this face. And an interesting point about that triangular cut is its point that we come to, if we were to draw it here like this, draw a triangle like that right there, that point has to come down from this surface here, down from this upper edge in the sketch, down to the same depth as this one is. Rather than using dimensions for that, here's the trick to get them to make sure they're at this exact same depth. Let's right-click on this face and start the sketch. Let's go normal to it. Let's choose our lines like this and that. And again, you have to close it up to get a closed surface. Hit escape to turn off the line tool. We know, well, now with the midpoint here, that's kind of nice. Let me go ahead and click this, hold Shift, click this, make them equal to each other. Click this, click this point right here, hold Shift, and click there and make them horizontal to each other. So now I've got my triangle. The width and the depth are the only things that aren't determined yet. And I said this depth had to be the same as wherever this guy is in here, wherever that line is passing down through there. We want that line and this point to be coincident with each other. The easiest way to do that is go normal to it and change your display style to the one that shows hidden lines. And that line right there is the line produced right here. So when you drag this over, you can just drag it to touch there, and that's automatically going to be at the right depth. Then just back to here, I can smart dimension just this one face here, like this. I did 0.15 before. Was that what I did? That looks about right. I don't know. Anyway, now we have a fully defined thing. Only one dimension is necessary. When we do our extruded cut now, of course, we don't want to do through all. Our end condition we want to do now is something called up to surface. And we select that surface. And now when we click check, it makes that cut that way. Very nice looking cut. By the way, while we're on the subject, that point right there where all of those come together is exactly what you want the threaded hole that's in this face to aim at. So when you go to do your hole wizard, that hole type, by the way, if you take a look at it, is a 1/4-20 on your drawing. And the end condition here, we only want it to come up to this next surface. We only want it to go from this surface to this next surface. So we're going to change the end condition here to up to next. And then we go to do our positions. Let me go normal to it. We go to do our positions. We'll need to make it transparent again, so we can see that point right there to drop that on. And once we've done that, you can see, puts that threaded hole directly in line. I can tell my dimensions are off, because if that's a 1/4 hole, it looks way too big for this part. So whatever numbers I was giving you in this little demonstration are irrelevant. It's mostly about the relations and how to use your transparency of a part to locate things that you can't see normally from that view, and how to use the select midpoint to help orient and align things. One last thing I want to point out is this other end of this part here actually has a cutout in it, and the cutout is kind of interesting. It's cut in such a way that this is shorter than the rest of it. This is like 0.6 or something, I don't know. Okay, and then this extrude cuts some distance back this way. I think in this case, to make it look sort of right, I'll make this 0.5. No, I did 1.2. Why? I don't know. 0.5. Let me try that again. Typed in the wrong place, I guess. Yeah, some cut like that. It's actually, there is an actual step down. And then on this face, if you're doing simple sketches, multiple features, you'll break it up this way. There's another point that's down here. It comes up to here, across to here, and down to here. And you'll be able to smart dimension that from the bottom up to this point here. Again, I don't know what it is, 0.16, I'm going to say, like that. But then the thing that's easiest to measure, and maybe is given to you, is the distance from this point to an equivalent point on a triangle on this side. So you have a choice here. You could either make this sketch a little more complicated by putting a center line in here, and I'll show you real quick. We can do it like this. And again, you're just watching. You don't have to actually do this. You put this center line in here, and if you remember, we did some other dimensioning earlier that involved a center line to a point, and it assumed you were going to reflect it around like a mirror. And so you can do that and type in whatever that dimension is on that part. Again, I don't know what it is. I'm making up a number here. And you can come out of that and do extruded cut up to surface here like that, and cut that. And then you could pretty easily then launch a mirror. The mirror face plane would be that one. And the thing to do is that cut. So you could do that. That's one way to get that cut out. Another way, if you didn't want to do that, is in this sketch here. Instead of using this center line, delete that and get rid of the dimension there at the same time, is you could just draw a second triangle like this. And then what you need to do with that triangle is you make this point and this point horizontal to each other, and you make this line and this line equal to each other. Now, there is one problem with my sketch here, and I'm glad I made this mistake, this error. When I was drawing my lines, I didn't quite connect these top two lines up here. I think it's probably those two. In fact, I'm 90% sure, because I started here to there, and it strings them together until you close it. But this is not actually this is not a closed contour. This one is, it's shaded, this one is not. Pretty sure if I zoom in on here, yep, look at that. This point did not quite reach that point. So if that happens to you, click merge with those points. And now, when you zoom out, you've got this image here now. You can see that's now shaded because those 2 points did actually hit each other. I'll be honest with you, it takes experience to recognize where exactly your open contour is. So most likely, if I hadn't been doing this for a long time, I wouldn't have known that right there is where I needed to look, and I needed to zoom in so much to see it. So I probably would have just selected all of those and hit delete and redrawn my triangle. Anyway, lastly, to make this work, you would just smart dimension from that point to that point here at 0.375, click check. As you can see, that's fully defined. And so without the mirror, you're able to make both cuts there. Anyway, that's just some advice about how to get started with this part. Again, none of these dimensions were right, but when you start to work on it, remember simple sketches, multiple features. So draw a rectangle before you draw a triangle, for instance. And this thing down here, it is totally true that I could have skipped, could have deleted, I could have done this instead. Let me delete all of these. It is true that I totally could have, instead of doing it that way with the rectangle and the two triangles, I certainly could have made a sketch on here that was much more complicated, something like this. I would have to make this one and this one equal, and I'd have to make this point and this point horizontal, and then I would have to smart dimension from the top. Oops. Smart dimension, actually I think it's from the bottom. I should probably dimension that up to here. This way, whatever it was. I don't really remember. And then this flat here, I'd have to dimension that. I don't remember what I did a minute ago. Like that. Let's see, I still have some blue in here, probably because this could, oh, I didn't dimension that yet. Whatever this was. I don't remember. So that, I could make that one really complicated sketch and then extrude cut that, whatever that distance was. That would work, but that's one complicated sketch and one feature rather than simple sketches, multiple features. So the first way I did that is superior to this way. This way looks like it's cooler in some ways because you draw this really neat shape and you cut it, but your chance of error rather, is much higher if you draw a really complicated sketch. You know, a rectangle and two triangles is a lot easier than whatever the heck you would call that shape right there. I don't even know what that is. So I hope this has been helpful. Really, the idea, though, is for you to work sort of independently to craft that part from the drawing. Your colleagues have been making it by actually measuring the physical part in the classroom. Honestly, there's not that much more to it, except for they get to decide what dimensions to measure. Whereas if I give you a drawing, you're constrained to the dimensions that I provide. So that's a little bit of a difference between drawing from life and drawing from or making a part from life versus making a part from a engineering drawing. Trying to think. I guess there's one other thing I could tell you here. You can also make a sketch on a surface in which no part of the sketch actually resides on that surface, like this. You see that sketch is sort of floating in space here. Because all it really means when you make a sketch on a surface is you're making a sketch on the plane that lies in that surface. And so when you go to make this sketch here, dimension maybe from here to here, I think it is, to make that cut, whatever it might be, you don't really have to draw it on this face. In fact, if you draw it on this face, you'll have a problem because it'll try to cut perpendicular to that face and slice your part in a really weird way. We want it to go perpendicular from this face, and in that way, slice the part straight across. So you can make a sketch on a face even if none of the sketch actually touches or cuts that face. Take that, extrude cut through all. So that's how you could do that. Again, let me explain this. I guess I didn't do a great job of explaining this. If I had, oops, that was a mistake. If I had made this sketch instead of on this plane, if I'd made it on that plane, here's what would have happened. And that's definitely not what we want. because it always cuts perpendicular to the surface. So since that surface is at an angle, it's cutting down like that. That would be quite faulty. So you don't want to do that. You want to make sure that you're on the sketch is on the plane you want to cut perpendicular to. Give me a little bit of an error here. Let's see what that was. I think I see what it is. This sketch is still error and an error. After I moved it, I made a mistake. Yeah, that point 2 got flipped around to the wrong direction. If that happens to you, just delete the dimension, move it to where you do want it, and reinstall the dimension. So that's an interesting error to have right then, something I could totally see one of you students making and not realizing what was going on. What's wrong now? Oh, wrong direction. There's another one. Yeah, I forgot about this error that people can make. Right now it's trying to cut that way, and so if you tell it, it's going to say the intended cut does not intersect the model. Because yeah, it doesn't touch material anywhere. It's cutting nothing continuously. To flip a direction on this, all you have to do is click this little arrow here next to your end condition, and it draws it back the other way. So all kinds of neat stuff, little details and tricks kind of tossed into this little lesson here. Best of luck with it. If you don't finish it by the time you return, you might be one lesson behind the others, but it should work overall. Email me if you have any questions. Best of luck. I'm not going to save this part because I don't really need it, but you should save whatever you do. And heal up, and I'll see you after Thanksgiving.